So now let's take a look at the VPTela fabric. So before we go deep in the fabric operations, we need to understand few terminologies. So the first thing is the site ID. On every VH router, we configure a site ID. Each site has to be a unique integer number. So for example, like the lab that we have set it up, we have 3 VH routers, one in New Jersey, one in Texas, one in California. We have 3 different site IDs, 100, 200, and 300. Has to be a unique number. Then the next thing is the system IP. System IP, you can identify each device with the system IP. It has to be unique also. So you have to configure a system IP on each device. And then organization name. Organization name is basically defined by Cisco. So whenever you order your equipment, they already configure an organization name on those devices. It is basically used to match the certificate authentication process. So if you don't have the correct organization name, you can't bring up that device into your network. Then OMP, OMP is a dynamic routing protocol. It's just like any other routing protocol like BGP or OSPF. This protocol manages the VPTela overlay network. Then we discuss the OMP, and then OMP has 3 types of routes. One is called V routes. V stand for VPTela routes. These routes are learned from the service side of a VH. So VH has 3 sides. One is the management side, one is the transport side, and one is the service side. So service side means when you connect the VH router to your existing branch network, let's say. So the branch network is the service side. So any routes that VH is learning from your existing branch office, those are the service routes. So these service routes, it learns from the local branch router, and then it distributes that routing information in the overlay network. Then the next one is the TLOC route. TLOC is basically, it's an identifier for the transport. So let's take an example, like if you have 2 circuits on a VH router, and those 2 circuits are the exit point from a branch office. So how do you know, or how do you configure that the traffic when exiting from the branch office, which path does it take, or which circuit does it take? So let's say if you have 2 circuits, circuit 1 and circuit 2, and you want your branch traffic to exit out from the VH, so you can specify that this type of traffic, let's say voice over IP traffic, it should go from circuit 1, and the application traffic, it should go from circuit number 2. So the TLOC is basically, it tells you, it tells the router that which path it has to take. So if you see, the TLOC is built up with 3 different attributes. One is the system IP, the second is the color, third is the encapsulation. System IP, as we discussed, is different for every device in the VPTela network. So on this router, you will have one system IP. So system IP will be same for both circuits, right? Then encapsulation, normally we use IPsec. So encapsulation will be same also on both circuits. So the only difference will be the color. The color means, so for, let's say the circuit 1 was your broadband circuit and circuit 2 was your MPLS circuit. So when you will define a TLOC, you will say system IP, then color, for color you will mention MPLS, and this for the second circuit, you will say for the color is broadband. So when you define this TLOC attribute, so the router knows that if I have to take voice over IP traffic, I will take it through the MPLS. If I have to take the application traffic, I will take it out through the second broadband circuit. So that's how the TLOC works. And then the service routes. Service routes are, as we mentioned earlier, any network services that you have, like firewall, load balancers, IPS, any intrusion devices in your network, and you want to announce those devices to the other locations. So these devices are located physically at one location, but if you want to announce these devices in the overlay network, then you can announce it through the service routes. So you can, in short, you can consider OMP. It works on the overlay, and TLOCs work on the underlay. So after defining these terminologies, now you can take a look at this SD-WAN topology. In this topology, we have multiple sites. You can see on the top, site 1 and site 2, then in the bottom, site 3, site 4, and site 5. And you have two different type of connectivity. One is MPLS, and the other one is the internet. So you can see this how every VH router has two connections. When the blue line is the MPLS, the red line is the internet, right? So now this is the site ID that we discussed. So each site is identified by a unique number. So you can see these are all unique numbers: site 1, site 2, site 3, site 4, site 5. Then it's the system IP that we discussed. So these are the system IPs. Every router has a different system IP. It's also unique. Third thing is the TLOC. So you can see those circles, the red circle and the blue circle, right? So the red circle is the internet type of circuit, showing the internet type of circuit, and the blue one is showing the MPLS. So if you take a look at the site 1 or site 2, all those VH routers have both type of connections. So they have a blue connection going to MPLS and a red connection going to internet, and these are two different TLOCs. So a red TLOC and a blue TLOC. So if you want any traffic going on the blue TLOC, you have to define a policy saying that take my voice over IP traffic from blue TLOC, and if you have any other type of traffic, you can say, okay, take this traffic on the red TLOC. And then this TLOC is basically built up of colors, so that's why we are showing it in different colors, blue and red, to distinguish between these two types of TLOCs. Now the network segmentation.
So going back previous slide, could you explain why R7, R8? What's the speciality here? That R7 is only MPLS, R8 is only INET. What type of connectivity usually is the reason for that? Just to give us a little more perspective.
There is no specific reason. These are different type of possibilities that you can have it. So in one branch office, you can have. So this is one thing that is basically called TLOC extension. It's the concept of TLOC extension. So if you see in site 5, both routers are connected to each other, right? They have two black lines between R7 and R8. But these lines are not there in any other site. So site 2 also has two VH router, and site 1 has two VH router, but they don't have these lines connected, right? So every router you have in those branch offices, they have their own separate connectivity with internet and MPLS. Here you have only one connectivity from each router. Like R7 has connectivity to MPLS only. It doesn't have internet connectivity. And R8 has only internet connectivity. So the advantage of this scenario is, for example, let's say if the MPLS is down, right, you can extend the TLOC to the R8 router, and you can still get traffic go out from that branch office through the internet connection from the red TLOC. And let's say if the red TLOC is down, because those two routers are connected to each other, VH routers, so traffic can still pass between those two routers and go out from the other type of circuit. So this is one of the advantages that is called TLOC extension. When you configure TLOC extension, then you don't need multiple circuit on the VH routers. You can have only one circuit, and if that circuit is down, you can still pass the traffic from the other side.
Is it something to do with the port saving, or what is the advantage of using?
Yes, cost saving is also there, because instead of getting 4 circuits, you have 2 circuits, and you are using TLOC extension feature, and you can still manage the connectivity.
Okay. it's
So let's
basically
say if you
saving
have
the
a
transport.
small branch office and that branch is not very critical, and you don't want that much redundancy on that branch office, so you can have only one type of circuit on each router, and you can configure T-lock extension.
Got it. Thank you.
So for network segmentation can be achieved by using VPNs. By default, there are two VPNs always present on all Viptela devices. When you order those devices, it comes with those two VPNs, and those two are VPN 0 and VPN 512. VPN 0 is your transport VPN, which carries all the control traffic over DTLS connections. VPN 512 is the management VPN that carries out-of-band management traffic. VPN number 1 to 511 is server-side VPN, where you connect your existing branch network. So the other term for VPN is also VRF that we use in the traditional network. VRF means virtual routing and forwarding. So VPN is same thing in the Viptela world. So it's same thing that you can interchange with VPNs and VRFs. And each interface can be part of a single VPN only. You cannot, if you have like one interface on a VH router, you cannot make it part of two different VPNs.
Faisal, is your VPN 511, if you have more than 500 branches, so are we using the more VPN
number of branches,
numbers, or just this is
it is not number of branches. You can have
total number of the range of the VPNs.
It has nothing to do with the number of branches. VPN 1 you can define in all branches. VPN 2 you can define in all branches. It's only when you want to segregate your traffic. For example, in your branch office, you have two type of users sitting. One is, let's say, financial users, and the other one is the administrative user, and you want to segregate their traffic, that financial users should not share their data with the other type of users, so you define two different VPNs, but it has nothing to do with the number of branches.
Okay.
All right.
And these are always on the service side, the 1 to 511. And then you don't need to define, just this may be a silly question, but Faisal, I want to ask it. You don't need to define a VPN for the transport, the data side, the side going through to connecting to other
So let's assume this: the VPN 0 is the VPN that is on the WAN side, which is the wide area network where you connect your carrier, MPLS, or internet broadband, right? And VPN 1 to 511 is your LAN side, where your local area network. So just to take an example, in your network that you have in Texas, right? You have a VH router. So VH router is connected to your internet. That is VPN 0, and then the VH router connected to the second Cisco router, which is sitting downstream to VH router. That is VPN 1.
Perfect. But then
All right.
you're just talking about controlled traffic, which is the overlay network. What about the underlay network?
So VPN 1 is underlay network. VPN 0 is the overlay network.
Okay.
VPN 1 is connected to your the internal branch network, so that is the underlay.
But that's the service side. What about the WAN side?
WAN side is VPN 0.
Okay.
WAN side is always VPN 0.
Perfect. But then you just talk about in VPN 0 the overlay, the traffic, the control traffic. What about the actual data traffic? Does that also go through VPN 0?
No. VPN 0 has only control traffic. Doesn't have the data traffic. Data traffic is on the... So every VH router create an IPsec tunnel to the other VH router, right? So the data traffic carries over the IPsec tunnel, not the transport side has only DTLS connections. So all the control traffic goes to the DTLS connection, and the data traffic goes on the IPsec.
So therefore you don't need to define a VPN for that data traffic because you're defining IPsec. Is that the right way to answer that question?
We are not defining, it's automatic actually. When you bring up any VH router, it automatically creates IPsec tunnel to other VH routers on the network, and it creates a DTLS tunnel with the controller for the control traffic.
So Faisal, can I add something to this?
Mm-hmm.
So visualize this, Ali, as Faisal had earlier mentioned that the VPN 1 through 511 is to do different routing instances. He didn't use the word routing instances, but understand the fact that it's a routing instance. So for example, he used finance versus engineering or whatever, right? So VPN 1 in our instance is a routing instance. So all the overlay networks are talking on VPN 1. The routes are being transferred and everything else is happening. VPN 0 is control connection. So what is transport VPN, right? So it's creating a control connection of how the underlay is working. You will not touch that, right? So what's going to happen
is VPN swapping underlay and overlay? I'm just confused. Control is overlay.
No, let me take you to the next slide. It will clarify something. See this one, right? So this is the box on the left-hand side, which is showing you the green, red, and the other white boxes. This is representing a VH router. Okay. So the red part, it has two interfaces. Right? One interface is connected to the MPLS. The second interface is connected to the internet. This is your VPN 0, which is connecting to the WAN side of the network. And then you have the green box. It also has two interfaces, which is connecting to your local area network in your, you can say, the existing branch network. It is connecting you to the existing branch network. That could be any VPN number from 1 to 511. And then the bottom part is showing out-of-band management connection. That has to be VPN 512. So whenever you order a VH router, it comes with VPN 0 and VPN 512. And then the green VPNs you build by yourself. And the outside zone, which is connecting to the MPLS and internet, it's showing in the red. The inside zone is green, and the management zone is the white box. And if you see the other picture on the right-hand side, you can see a V-edge. It has a management side, it has a transport side, and then the bottom one is the service side. So this is exactly same scenario that you have in your network in Texas. You have a V-edge, which is connecting to the internet on VPN 0, and you have VPN 1, which is connecting to your other Cisco router on the service side. Is it much more clear now, or is there any confusion yet?
Very good. And then this transport side, it has both the control net traffic and the data traffic. You know the control plane and data plane? Does the transport side carry both data and control plane?
So see, there are two things. One is the physical connectivity and one is the virtual connectivity. Okay, just keep in mind.
Yes.
So you have a VPN 0, which is only transport. This doesn't have any data, right? And then you have VPN 1, which has the data traffic. Both uses the same physical connectivity, but they have two virtual paths. VPN 0 take a virtual path which was built on DTLS. VPN 1 take a virtual path which is built on IPsec.
Okay, this is exactly what Khalid was also saying. So this is IPsec, but then there is two sides of this. One is the service side, the LAN side, and the other is the WAN side. Those aren't virtual.
Yeah, but this LAN side traffic, let's take an example. You have another branch office, and it has exactly same setup. And this VPN 1 traffic, you want to send this VPN 1 traffic to the other side of the network, which is the branch number 2, and they also have a VPN 1. So you want to share VPN 1 traffic from branch 1 to branch 2, then your traffic will take the path, the same path, the transport side, but it will create an IPsec tunnel from branch 1 to branch 2, and then the data will transfer from VPN 1 on branch 1 to VPN 1 in branch 2.
Much clearer now. Thank you.
So this is the Viptela fabric. As we mentioned earlier, the Viptela fabric is built on hub and spoke. So we also call it route reflector model. Route reflector model is basically a different term for the hub and spoke. So it's same thing. Route reflector or hub and spoke is same thing. So and route reflector is the terminology that we use in BGP protocol. That's why the Viptela also mentioned this terminology in their network, so that anyone who is experienced in BGP, they can get the concept right away. So the controller, the vSmart controller is basically a route reflector server, and all the VH routers, they behave like a route reflector client. So what does it mean is basically, as we mentioned earlier, that all VH routers, they create a tunnel with the central controller. They don't create any control traffic tunnels between themselves. They only create to the central controller. Central controller get all the routes, and then it is the one who distribute those routes to other VH routers. So it's a client-server model, you can say. So all the VH routers are client, and the controller is the server. So route learns from each service side, the local network at each branch office. The VH router at that branch office is responsible to advertise those routes to the centralized controller, and then vSmart controller then passes the information to other VH routers in the overlay network. So if you see this picture, you can see that on the right-hand side you have your data center, you have your cloud, IaaS, infrastructure as a cloud, SaaS, you have some other virtual data center. All the applications are sitting over there. And then on the left-hand side, you can see you have users, you have devices, you have other things which are connected on the network. And every location, every data center, or every branch office, you have a VH router. So, and then on the top, you can see you have all the SD WAN controllers over there. So it's end-to-end a fabric, a single fabric that Viptela creates. So all the blue area that you can see, it's a fabric that is created between the VH routers and the controllers, and all endpoint things, applications, users, devices, they communicate through this secure fabric. So how does the secure tunnel establishment take place? Here we can define in this diagram, you can see the vSmart is on the top, and then we have three different VH routers, VH 1, 2, 3. And you can see the purple tunnels, which are the IPsec tunnels. These tunnels, the VHs create IPsec tunnel between them to pass the data traffic, or you can say application traffic. And then at the same time, they also create DTLS tunnel with the vSmart. And DTLS tunnel doesn't carry any application or data traffic. It only carries the routing traffic. So the first point here is VH establishes a secure DTLS tunnel with vSmart for control traffic. VH also establishes a secure IPsec tunnels with the VH for data traffic. DTLS tunnel is established after VH is successfully authenticated by vBond. So whenever a new VH comes up on the network, first it gets authenticated by vBond. Once it is successfully authenticated, then only it can create tunnels with the other devices in the network. DTLS sessions between vSmart and VH is permanent. These tunnels, they are permanent tunnels. They always stay there as long as the VH device is up and running. The DTLS session between vBond and VH is a temporary connection and tears down after VH is authenticated. So every time a new VH comes up on the network, it goes to it creates a tunnel, DTLS tunnel with the vBond. vBond authenticated. Once it is authenticated, then tunnel drops. It tears down that tunnel. It doesn't need that tunnel for any future communication. So Once it is authenticated, then it can communicate directly with the vSmart and vManage. It doesn't need vBond anymore. So this is just to show you the tunnel establishment process. Like if the top box is showing you the authentication between vSmart and vBond. So when vSmart comes up on the network, it asks vBond to authenticate me. vBond check the chassis ID and whatever the certificates and other stuff that it need to check. And once it sees that those are valid, then it says it sends a message back to vSmart saying that you are valid, and then it says authenticate me, and you are valid, and it says get authenticated, and the DTLS tunnel established between vSmart and vBond. The second box is between vEdge and a vBond. The same process takes place. When vEdge comes up, it says authenticate me, and it validated, and then after that it sends the IP address or the other information. If we have a template configured, then it gets all the information through vManage, and it comes up. Same thing with between vEdge and vSmart. And so once everything is authenticated,
sorry, I want to nitpick the previous slide. Sorry, there is something. I love the detail you're going into, Faisal. That's why the questions. So please, we're following you and loving this. The second box you said, vEdge is only getting authenticated by vBond, and that's the only relationship. Is that why there is no DTLS connection needed between vEdge and vBond?
No, so DTLS connection is needed initially during the authentication process. Once the authentication process is done, then there is no need for that's why it is not showing the DTLS connection. So as I mentioned in the previous slide, that this is a temporary connection, right? So it builds the DTLS session initially, and then it drops it tears it down. So that's why they are not showing a permanent connection. They are showing only permanent connection here.
So by tearing it down, it reduces the beauty of this design is there's no need for it. You reduce signaling load by not tearing it down once it's needed.
There is no purpose of that tunnel to stay, right? This connection is only for authentication. Authentication is done now. We don't need to communicate anymore. That's it. So here is the Viptela Fabric architecture. Once all devices are authenticated by each other, then the network comes up, and it looks like this. You have a vBond sitting on the top on the orchestration plane, which authenticate all devices. Then you have a vManage, from where you can manage the entire network. Then you have multiple vSmart controllers for redundancy, and you have different type of transport, MPLS, Internet, 4G, and in the bottom you can see all the vEdge routers sitting in the cloud, data center, campus location, branch office, or a small home office. So, and they are creating end-to-end. You can see those red locks. They are creating IPsec tunnels between themselves.
And this is the beauty of what you explained, VPN 1 to VPN 5.11. So I would imagine in a real-world implementation, Khaled, Faisal, for both of you, these VPNs, you usually don't use one VPN. You break it up into multiple VPNs depending on the type of different offerings. Is that correct?
Yeah, you can run your entire network on one VPN, like all your service-side part of VPN 1, let's say. But if you have any other requirement that you want to segregate your traffic, then you define multiple VPNs.
And usually that is not something you control. That is the way the network has already been architected for the traditional MPLS world. You inherit that, and you have to maintain that when you introduce in vEdge. Is that correct?
So let me give you a real-world example on this. So what we do today is in a flat network or a routed network with close to 400 sites, is we put medical equipment behind restricted firewalls. Okay, The reason to put those devices between restricted firewalls is that nobody else can touch them. Agreed? But some people do need to touch them. Those are the medical staff that needs to touch those devices. So we end up putting firewalls and firewall policies. Pretty expensive. It's about $30,000 per site. So the way to get around that is if you define VPN 2, and in that VPN 2 you define the medical devices and the subnets that are allowed to access it, you can have a company-wide policy. And you save $30,000, $40,000 per site by avoiding that. So that's where this comes into play. A different routing instance or routing domain.
Perfect. But building on that, wouldn't your existing DMVPN technology take care of that, or would you need Viptela?
So in DMVPN, what happens is there's a concept of VRF, which Faisal briefly touched on. You do it via VRF, right? But that doesn't come into play into how would you say? Yeah, technically you could, but what will happen is then you'll have to define VRFs internally also and on all sites. You could do that.
Let me rephrase it. I will give you a better explanation. So you are aware of those terminologies as tenant and multi-tenant environment, right? So whenever we say multi-tenant environment, this is from the service provider perspective. Let's say Verizon, right? So Verizon have a big network and they have hundreds of thousands of customers. So what they do, they create multiple VPNs for multiple customers. Like, for example, if HTN Network, they go to Verizon and ask them that we need a service, MPLS service from you. So what they do, they create a VPN for you, right? Let's take an example, VPN 1, created for HTN Network. Now, Viptela also go to Verizon and say that we need MPLS service from you. They will create another VPN, VPN 2, because they don't want to mix HTN routing information with another customer routing information, right? So these are completely two different routing instances. So you are also going through the physical network of Verizon, but your routing information is completely separate from the routing information of another organization which is also getting service by Verizon. So these are, and then they have multi-tenant. They have so many thousands of customers. Every customer has their own VPN. They don't keep information mix between, because maybe I am using the same IP address that another organization is also using. So that's why they keep all the routing instances separately so that you don't have any conflict, and also from security reason. One company has their own VPN, their information won't go out from VPN 1 to VPN 2 and vice versa. So every tenant has their own VPN, and this is called the multi-tenant environment. And in case, let's say you have two companies. You have HTN Networks and HTN Wireless, and now these are two sister companies, and you want some information to be leaked between these two companies. Then there are ways that you can configure policies and you can leak routing information from one VPN to another VPN. By default, there is no policy. You cannot leak any information from one VPN to another VPN, but if you want, you can do that. And even in Viptela, there is a feature that you can leak the information from one VPN to another VPN.
Okay. So when you say multi-tenancy, it means that they're using the same Viptela fabric, the same vBond vManage, but they are trying, because like it's a Verizon hosting it, and now they're trying to create that segregation using VPN architecture in a multi-tenancy situation.
It's not Viptela. It's a general terminology used in the market, multi-tenant. It could be anything, any other software vendor or any other hardware vendor, but it's called multi-tenancy because you are allowing so many tenants in one network, but you are keeping everybody's information separate. It's like a bank account. Like you have a bank account in Bank of America. I have a Bank of America account. I cannot see your information. You cannot see my information. As simple as that.
Thank you, sir. I hope that what we're seeing is the richness of our storytelling, Faisal, between you and Khaled, Faisal. I think the way you're presenting it is much richer than the material I've seen on the web. So thank you very much.
Thank you. I think I'm running short of time. I have lot of more slides to go. So
The
let's
objective
move
is
on.
to learn something with richness, not with just words. And you're adding a lot of value for a guy like me. And I think I am enjoying it. I can't say for Tariq and Farad, but I think we are enjoying the discussion.
All right, I appreciate. Thank you. So this is the bring up sequence of Viptela components. When we bring up the Viptela network, this is the process. So the first thing is, so when we bring up the Viptela devices, it includes the authentication process and validation process. All Viptela devices authenticate each other, and then once everything is authenticated, then the overlay network comes up. So first thing is the vManage, as we mentioned, vManage, vBond, and vSmart. These are software entities. So first thing is when vManage software is started on a server, either on-prem or in the cloud. Then the second thing, vBond orchestrator start up on a server, either on-prem or in cloud. And same thing with vSmart controller, it is start up in the cloud or on the on-premises. So these three software comes up first, right? And then the vManage and vBond orchestrator authenticate each other first. So the process is first all three devices comes up on the network, then vManage and vBond, they authenticate each other. And after they authenticate each other, then vManage and vSmart controller authenticate each other. And after that, the third step is vSmart controller and vBond authenticate each other. So that's how I'm going a little bit fast because I have to cover a lot more slides. But the main idea is all three software entities comes up on the network, then they start authenticating each other. The vEdge router, they comes in the last. So first all the controller devices comes up on the network, they authenticate each other. And then when we bring up a vEdge router, it is start on the network. The vEdge router authenticate. The first it go, because on the vEdge router we have the minimum configuration when it comes up on the network. The minimum configuration is it has the IP address of the vBond. So it go to vBond first, and vBond authenticated. Once it is successfully authenticated, then vEdge router get authenticated against the vManage. And then the third thing, and if you have a template configured for that vEdge router, so initially it comes up with the minimum configuration, and when a template is configured on the vManage and vManage authenticated, then it basically get its full configuration from the vManage, and vEdge router get configured automatically by pushing the configuration from the vManage side. Then vEdge router, once it is authenticated with vBond and vManage, then it go to the vSmart controller and get authenticated with vSmart controller, builds the DTLS tunnel, and if tunnel is successfully established, then the vEdge router comes up on the network. And the vEdge, the hardware-based vEdge routers, they support something called zero-touch provisioning process, and we'll explain the next slide what exactly is the zero-touch process. So here is the zero-touch process. The first thing is you have turned on the vEdge router. The hardware router powers up. The router contact a DHCP server because the port, the WAN port on this router is by factory default configured for a DHCP. So when you connect it in your network, the DHCP server in your network assign an IP address to the router. Once it get the IP address, it start communicating over the network. It go to the DNS server, which is also get the information from a DHCP server. So basically, DHCP server provide IP address to the VH router, and DNS server IP address to the router. So once it get the IP address, the VH router, and it has the DNS information, it go out on the internet and it try to resolve this ztp.viptela.com. It try to resolve this ztp.viptela.com. Sorry. And then when it contact the ZTP server, the router connect to the ZTP server. The ZTP server verifies the router, VH router, and sends the IP address of the VBond orchestrator. At that point, VH router doesn't go directly to the VBond. It go to the ZTP server. ZTP server, it send it to the VBond orchestrator. So this VBond orchestrator, that is the same orchestrator that they configure using the organization name on your router. The router establish a connection with VBond orchestration and send its chassis ID and serial number. Those are the two items that VBond check, and then based on this information, it authenticate. So at this point, the router does not have a system IP address, because system IP address is something we have to do it manually. So at this point, it doesn't have the system IP address. So the connection is established, but it has a null system IP address at this point. So VBond orchestrator use only the chassis ID and serial number to verify the router. The VBond orchestrator then send the IP address of the vManage to the router. So router go to VBond, and VBond tell the router, okay, you are authenticated. Now this is the IP address of the vManage. Go to vManage and get your configuration from there. So the router establish a connection to the vManage, and is also verified by the vManage that this is the router is authenticated to get the configuration. The vManage sends the router, if you have a template configured, then it will send the router the system IP address, because initially it has a null system IP address. So vManage will send a system IP address. So there are two ways. Either you can configure a system IP manually, or if you have a template, then vManage will send the system IP address to the VH router. So now VH router, it went to initially VBond. VBond has given him the IP address of the vManage. It went to vManage. vManage gave him initial basic config, and it has now the router has its system IP. It got the system IP from the vManage. Now, once it has the system IP, because the VBond, when initially it has contacted VBond, at that point it doesn't have the system IP. So VBond doesn't know him with the system IP, right? It knows him only with the chassis ID and the serial number. So now once it gets its system IP, then it go back again to the VBond orchestrator. So the router reestablish a connection with the VBond, and now VBond register him with the system IP address, with the chassis ID and serial number. So at this point, router reboots, and after the reboot, it reestablished connection with the VBond. VBond verify the router with all three parameters now: chassis ID, serial number, and system IP. Then the router established the vManage connection again, which and gets its full configuration. In first attempt, it gets only system IP. Second attempt, it gets its full configuration. So once it gets the full configuration from the vManage, then router go and establish the tunnel, GTLS tunnel with the vSmart controller, and then join the organization overlay network. So that's how the process is. So in the bottom, you can see a small cloud, which is the overlay network here. So it goes through with all the steps from one, when you turn on the router, from off to on, Then it goes to the DHCP server, get the IP address, then it get the information from the DNS server, then it go to ZTP server. ZTP server, it send it to the vBond server. vBond server give him the IP address of the vManage, and then vManage it gets the system IP. Then it reboot, it go back to the vBond again, and then it establish the connection with the vManage, and then finally once everything is done, then it comes up on the overlay network. So that's how the ZTP process takes place. In the explanation, it looks like a very complicated process, but it is like 5-minute process. When you turn up a VH router, it comes up, it performs all these steps, and it is on the network within 5 minutes. So
we saw that only the one router came up like this. The one on my side didn't, but that was because of a name mismatch. But what was the reason you guys took 4 hours to get the second router working for Khalid? What was the reason if it's that simple?
Yeah, both routers have some typo in the organization name, and that's why they were not coming up.
And regarding
the only router which came up right away was the Haris router, because he didn't play with the organization name on that router, so came up right away.
So regarding the New Jersey router, as you recall, it had a faulty port. That router has been swapped. Cisco sent a new one, and it came up with no issues. Well, we had to go through. There's a process when you do an RMA.
I remember now that router has a hardware issue also. So the transport side of that router wasn't coming up, the WAN interface, so it has some hardware issues. So we reconfigured one of the LAN interface as the WAN and tried to bring it up on the network. So it was a combination of hardware issue plus the organization name, typo in the organization name.
Just to build on that, Faisal and Khalid, as we start building our POC, one of the critical build processes is the zero-touch process. And now that our routers are up and running, can we do this again? Or do we have, meaning can we go through it ourselves just to make sure we know how to do it?
Yeah.
No, you reboot your router, you turn it off, turn it on, it will go through a ZTP process.
Okay, again, it will always do the same steps.
Yeah.